In our previous lesson, setting up our compound worksheet, we added an image for the future value function and then added another column. That was not part of a video, but was within Google Classroom. So if you don't have that done, what you would want to do is navigate over there. And it was this item right here, Update Compound Interest Google Sheet, and provided you with an image to download, and then also an image of how to adjust your sheet and make it look like this. And we added this column here, column G, FV function, future value function. And so with that complete, then we can go ahead and learn another way to calculate an amount or a future value utilizing this thing called FV, the future value function. So in lessons 1 through 3, we applied this particular compound interest formula to calculate this amount. And so we applied this algebraic formula here and learned how to use exponents within Google Sheets to calculate the amount of money we would have over a period of time given a certain principal amount, a rate of interest, and how often it was compounded. So here in Google Sheets, and this is also available in MS Office through Excel, same function, is we want to learn how to apply that mathematically in order to calculate the same amount. So I'll go ahead and demonstrate that right here. Future value function. As always, we always start out a formula with the equal sign. And we're going to refer to this image. The way we're going to use the function is that we are only going to need the rate, Nper, which is the number of periods that it's compounded. We're going to skip payment. We do need the present value, otherwise known as the principal amount. And we will also skip the type and let it default to type 0. So we just really need 3 of these variables in here to calculate it. So you're going to find out that it's a little bit faster than the way we did it previously using the compound interest formula. So equals FV, and it can be lowercase. It doesn't have to be capitalized. Need a parenthesis. And so the first value we need, otherwise known as an argument within this Excel Google Sheet talk, is that we need the rate. And the rate has to be expressed as a decimal value. And so for this problem, it's 0.025. So we need to put that in as a decimal value. And the other thing we need to consider is this, is that 0.025, which is 2.5%, that is an annual interest rate. And so if we're going to be compounding something other than in years, then we are going to have to divide that by the number of those compounding periods. So we want to get in the habit of doing that, even though for this particular problem, number 1 here, it's compounded annually. We are going to go ahead and get used to dividing this by the number of compounding periods within a year. And in this case, because we're compounding once a year annually, we would divide that value by 1. Now we could get the same calculation by just putting 0.025, because dividing it by 1, it's going to remain 2.5% there. But we want to get in the habit of doing that with this future value function. Then we have to separate that with a comma. And then the next item that we need is here, Nper, the total number of payment periods. So because it's being compounded annually, 1 time a year, but it's being compounded for a total of 2 years. So the number of compounding periods then would be a total of 2. And we are going to enter that as 1 times the number of years, which is 2. And then we need another comma. Next, we are going to skip payment. But because we're going to skip it, we still have to put in a comma to at least show that we are just leaving it blank for now. So it's kind of like a placeholder. Next, we need the present value, which is also the principal amount. Now, in order to have this reflect a positive number, we have to enter the principal in as a negative number. And it's a feature of Google Sheets, and Excel that the way the numbers are calculated, cash flows, inflows and outflows are handled in a way that that part of it's negative, the other part is positive. So we need to put that value in as a negative in order to have it reflect a positive value in our answer. So if we've done everything correctly, we should get the same answer, $57.78. And there it is. Let's do one more, and then I'll let you go to work on these. Equal sign, FV, parenthesis. First we need the interest rate. Here it's 2.55%. We'll have to enter that as a decimal value of 0.0255. Now notice here that it's quarterly. That means 4 times per year. So that interest rate will have to be divided by 4. Comma. Next, how many total compounding periods will there be? The total number. So it's going to be done 4 times per year for 4 years. So we want to put in number of times per year times the number of years, which will equal a total of 16 compounding periods. Another comma, and then because we're skipping the payment, we need to put in that placeholder comma, and then we need the present value or the principal amount. In this case is $2,500, and we have to show that as a negative value in order for the calculation to work the way we want it to. Another parenthesis, enter $2,767 and 56 cents, $2,767.56, and it has worked out the correct way. So go ahead and finish the rest of these, and you will see you will need to make some adjustments. Monthly is going to be 12 times a year, daily 365 compounding periods. Once you finish that, those of you in class can show that to me, and those of you at home, go ahead and complete this, and later in the week I'll have you submit a copy. Make sure you ask any questions. It takes a little bit of practice. Easy to make a mistake. Don't worry about it, and we'll get you through it. That'll conclude this video 4 of applying the future value function here in Google Sheets, and also it will work in Excel.